a little detour in our work with three-dimensional geometry today to start to look at something called defined operations. These are basically fictitious operations that are defined within the problem, and then you evaluate the problem using the operation. These kind of problems show up in standardized tests from time to time, and you'll see them on the SAT test, so it's a good opportunity to take a couple days and practice with them. They're kind of fun also. So the first problem I want to do is problem number 10. This operation is defined this way. This is called a tilde. So tilde A tilde is equal to 5 multiplied by A plus 2. So basically you substitute the whatever value you get for A into this equation or this function when you see this operation. And they'll typically give you an example, not always, but many times you'll get an example. It'll say, for example, if A was 4, your function would equal 22. And whenever I'm given an example like this, I like to just check it to make sure I understand how the function works. So if this is supposed to be 5A plus 2, and A is 4, then 5 multiplied by 4 plus 2 should be 22. 5 multiplied by 4 is 20, and 20 plus 2 is 22. So it just gives me some confidence that I understand the way the operation is supposed to work. So now we'll just apply that operation to negative 3.1. The function is 5a plus 2, and in this case a is negative 3.1, so 5 multiplied by negative 3.1 plus 2. 5 multiplied by 3 and 1/10 would just be 5 multiplied by 3 plus 5 multiplied by 1/10. So I have 15 and 5/10, and a positive multiplied by a negative is negative. So negative 15 and 5/10 plus 2. These aren't integers because this one is not an integer, but you treat the operations the same way you would if you were adding integers. Negative 15 and 5/10 has a greater absolute value than positive 2, so we're going to end up with a negative sum. And if a number line model helps you to visualize this addition, you could use one. If 0 is here and I'm at negative 15.5, if I'm adding 2, I'm going 2 to the right. So I'm just moving 2 to the right from the negative 15.2, so I'll be at negative 13.2. I'm getting closer to 0, but I'm still in the negative, so negative 13.2. You could also find the difference, 15.5 minus 2. Should have lined those up better. And you get 13.5, and then just realize that it has to be negative for this reason. So negative 13.2 for number 10. I also want to do problem number 15 with you. 15 is a little different. The operation is defined differently depending on whether the variable is odd or even. So this operation is defined as 2x if x is odd and 3x if x is even. So in the example that's given, when the variable x is 4, that's an even number, so you triple it to get 12. And when the variable x is 3, that's an odd number, so you double it, and 2 times 3 is 6. So why don't you try that for this problem and come back and see how you did.
Paused.
Okay, when I evaluate this operation with 7, I need to use the function 2x because x is odd, so 2 multiplied by 7. And then when I evaluate the operation with a variable where the variable equals 10, I need to use the function 3x because that's an even number. So 3 times 10. 2 multiplied by 7 is 14. So 14 minus 3 multiplied by 10 is 30. 14 minus 30 is negative 16. 14 minus 30, subtracting is the same as adding the opposite, so it's the same as 14 plus negative 30. You could do 30 minus 14 to get the 16, and then just realize it's negative because negative 30 has a greater absolute value than 14. So we would have negative sum, or, well, difference as it's written here. Okay, I hope that helped with the homework. I'll see you tomorrow.